Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to your first lesson on molecular orbital theory. Previously, we discussed valence bond theory. We talked about the hybridization involved in compounds containing multiple bonds. We learned how to determine the type of hybrid orbital on the basis of the electron structure of the central atom of a molecule. We also learned how to predict the geometrical shapes of molecules on the basis of hybridization. We discussed sp, sp2, and sp3 hybridization. We also talked about hybridization involving the D subshell and how two hybridized groups orient themselves with respect to one another. In today's lesson, we will explain molecular orbital theory. We will describe molecular orbitals using atomic orbitals, and we will look at combinations of some molecules and ions of atomic orbitals. Students, it is important to note that valence bond theory has certain limitations. It does not adequately explain the magnetic or spectral properties of molecules. Molecular orbital theory, on the other hand, can be used to describe the stability of certain molecules. It is a way of accounting for covalent bonds that depends on quantum theory and mathematical principles. Molecular orbital theory is based on the fact that electrons are not tangible little dots, as they are portrayed in Lewis structures. The fact that electrons are delocalized is less important in valence bond theory. We are only able to discuss energy levels and spatial probabilities through estimation. We estimate by thinking of quantized electron distribution as atomic orbitals. Students, as a review, please describe what atomic orbitals are and their purpose.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure that you had no trouble with this activity. An atomic orbital is a mathematical function that describes the wave behavior of either one electron or a pair of electrons in an atom. Atomic orbitals can be used to calculate the probability of finding any electron of an atom in any specific region around the nucleus of an atom. In other words, they can be used to determine the region where an electron is likely to be. If your answer was similar, then you are correct. Quantum mechanics treats electrons in atoms as matter waves. As a result, atomic orbitals are produced. The way in which electrons are treated within molecules results in the production of molecular orbitals. Atomic orbitals are able to combine or overlap in order to create new electron distributions. The new electron distributions are referred to as molecular orbits. In other words, when atoms combine to form molecules, the valence atomic wave functions for the bonded atoms are added together. Molecular orbitals are thus mathematical descriptions of regions of high electron charge density in a molecule. For every atomic orbital, there exists one molecular orbital. All of this is quite easy to understand in principle. We attempt to find an arrangement of appropriately placed atomic nuclei and electrons. The purpose is to produce an energetically favorable and stable molecule. The goal of molecular orbital theory is simply to describe molecules in a way that is similar to how we describe atoms. Molecular orbital theory attempts to describe molecules in terms of orbitals, orbital diagrams, and electron configurations. However, the concept becomes slightly more difficult when we try to construct a wave equation for a system that has several particles. We often attempt to write approximate wave equations by relating them to atomic orbitals. Students, let us do an activity. In a moment, sentences regarding this lesson will appear on the screen one at a time. However, certain words will be missing from the sentences. Please fill in the missing words to complete the sentences. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to complete all of the sentences correctly? Let us go through them together. Molecular orbital theory can be used to describe the stability of certain molecules. The way in which electrons are treated within molecules results in the production of molecular orbitals. Atomic orbitals are able to combine or overlap in order to create new electron distributions. The new electron distributions are referred to as molecular orbits. The goal of molecular orbital theory is simply to describe molecules in a way that is similar to how we describe atoms. Molecular orbital theory is a way of accounting for covalent bonds that depends on quantum theory and mathematical principles. Great work, everyone! That was a challenging activity, but I am sure that you all did a good job. In today's lesson, we discussed molecular orbital theory. We learned that the goal of this theory is to describe molecules in a way that is similar to how we describe atoms. We learned that molecular orbital theory attempts to describe molecules in terms of orbitals, orbital diagrams, and electron configurations. In our next lesson, we will continue learning about molecular bond theory. We will learn about bonding and anti-bonding molecular orbitals. We will also discuss and observe energy diagrams for mononuclear diatomic molecules. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.